sovereign country with respect to rich economy. Now, in that direction, government has established Vikasit Bharat One Sankalpam and another Sankalpam, National Quantum Mission. So you see, ఈ రోజుల్లో ప్రపంచంలో ఉన్న 140 దేశాల్లో భారత ఇంజనీర్లు, సాఫ్ట్వేర్ ఇంజనీర్లు పనిచేస్తున్నారు. There are people, Indians working in 147 countries across the globe. And Indians have showed their supremacy in IT. భారతీయులు ఐటీలో వాళ్ళ యొక్క ఆధిపత్యాన్ని చూపిస్తున్నారు, కొనసాగిస్తున్నారు. సో ఇదే ఆధిపత్యం, taking this background, I want to explain some statistics. So last year, 2024-25, the exports with respect to IT is a tune of $225 billion. Please remember, $225 billion. So which was $190 billion, 21-22. Now let us compare our math ability, that is the intellectual ability of this nation. That UAE, United Arab Emirates, the total oil exports cost around 190 billion during last year, which is much below than our IT exports. And coming to Saudi Arabia, so their oil exports are to the tune of $350 billion. So India has established its mission through National Quantum Mission to reach the exports to the $1,000 billion. $1,000 billion can save this country from poverty, can provide better facilities to the citizens, can give every service to the citizens like a developed country. So giving the call, based on this call, I have proposed to AICT that quantum computing should be the theme of the conference, and deep tech innovations. Innovations are very much important because China has prospered because of innovations. China, innovation after 1980, they developed to this state. Now they became second world's biggest economy. So we are aiming to become third world's biggest economy by another 2 or 3 years. So through these missions, we want to achieve. And what about quantum technology, quantum know-how, quantum ecosystem? So this is not much prevailing in India. భారతదేశంలో quantum technology గురించి skills developments అంత పెద్దగా లేదు. So government has allotted 6,000 crore rupees for National Quantum Mission, sovereign country with respect to rich economy. Now in that direction, government has established Vikasit Bharat One Sankalpam and another Sankalpam, National Quantum Mission. So you see, ఈ రోజుల్లో ప్రపంచంలో ఉన్న 140 దేశాల్లో భారత ఇంజనీర్లు, సాఫ్ట్వేర్ ఇంజనీర్లు పనిచేస్తున్నారు. There are people, Indians working in 147 countries across the globe. And Indians have showed their supremacy in IT. భారతీయులు ఐటీలో వాళ్ళ యొక్క ఆధిపత్యాన్ని చూపిస్తున్నారు, కొనసాగిస్తున్నారు. సో ఇదే ఆధిపత్యం, taking this background, I want to explain some statistics. So last year, 2024-25, the exports with respect to IT is a tune of $225 billion. Please remember, $225 billion. So which was $190 billion, 21-22. Now let us compare our math ability, that is the intellectual ability of this nation. That UAE, United Arab Emirates, the total oil exports cost around 190 billion during last year, which is much below than our IT exports. And coming to Saudi Arabia, so their oil exports are to the tune of $350 billion. So India has established its mission through National Quantum Mission to reach the exports to the $1,000 billion. $1,000 billion can save this country from poverty, can provide better facilities to the citizens, can give every service to the citizens like a developed country. So giving the call, based on this call, I have proposed to AICTE that quantum computing should be the theme of the conference, and deep tech innovations. Innovations are very much important because China has prospered because of innovations. China innovation మూలంగానే after 1980 they developed to this state. Now they became second world's biggest economy. So we are aiming to become third world's biggest economy by another 2 or 3 years. So through these missions we want to achieve. And what about quantum technology, quantum know-how, quantum ecosystem? So this is not much prevailing in India. భారతదేశంలో క్వాంటం గురించి, క్వాంటం టెక్నాలజీ గురించి స్కిల్స్ డెవలప్మెంట్స్ అంత పెద్దగా లేదు. సో గవర్నమెంట్ హ్యాస్ అలాటెడ్ 6,000 crore rupees for national quantum mission for the next 5 years. And they are establishing the quantum technology labs in 100 colleges across the country. So, and taking the advantage from the NQM, government of AP also has established.
So here the traditional climate models, that is the having that high computational cost, and those are that very limited accessibility, so that we move for this particular machine learning based adaptive alternative modeling analysis. So here that my very important point is nothing but we moved from that equation based analysis to data driven based for the forecasting of the long term data analysis. So here we use that very complex data, and based on those data we represented here. What are the core objective of this paper is nothing but, so here that the model long term climate behavior, so using machine learning we are making. Department from PBIT University, Guntur, Andhra Pradesh. I'm very happy to present my paper, this PodNext 2026 conference. My paper is having the title Machine Learning Based Climate Change Modeling Long-Term Temperature Forecasting. So temperature forecasting is a very important nowadays, because if there is no climate, so environment stability, then the agriculture or power generation on drone-based applications are not suitable. So we can't apply that proper work to the required field. So that it's very important to forecast that temperature and climate changes. So in these aspects, I want to give that my total research work in this particular paper. So my co-authors are also listed here. Now I want to go for that outlines of this presentation. So these are that outlines of the presentation. So I want to cover what are the introduction of this particular research paper, and where we motivated, and what are the core contributions we involved in this particular paper. I want to explain detailedly, and proposed system models and results and discussion I want to discuss in this particular paper. After that, the valid research references listed in this paper. So those are very helpful information for the development of this paper. Now coming to that introduction part, so already I stated that the climate change is a very crucial factor. So for the environmental stability and energy transmission and drone applications and agricultural and long-term sustainability also. So the accurate long-term temperature forecasting is a very important factor in nowadays. So whereas coming to that conventional physics-based environmental climate change prediction is somewhat costly, and it has a limitations. So that we move for that. So machine learning based data-driven, so complex data analysis can be done with help of the machine learning. So in this way, the recent ML advancement so is adaptive climate modeling solutions we are getting from this paper. So here that the key idea is nothing but this work explores how the machine learning so can model the complex climate behavior, so and improve the long-term temperature forecasting as in the
Artificial intelligence.
Thank you, sir. You gave a very excellent presentation. So can I have a copy of this? Can I have a copy of your presentation?
Thank you. Cognitive computing is the next stage of artificial intelligence, where machines can understand, reason, and learn from data, not just process it. You have to learn from it, Just to do data processing is not sufficient. So artificial intelligence is there, you get more data and you learn from that data and add it, so then it becomes cognitive computing. Is the next stage of artificial intelligence where machines can understand, reason and learn from data, not just process it. This is given by next Bernard Marr. Okay, next definition of cognitive intelligence. Cognitive computing refers to the integration of artificial intelligence technologies. Just this very important slide, just see. Cognitive computing refers to the integration of artificial intelligence technologies and various disciplines such as natural language processing, machine learning, and neural networks to create systems that can understand, learn, and interact with users in a manner akin to human cognition. So, how do you get cognitive computing? So, this is the next. Unlike traditional computing models, cognitive computing systems are designed to analyze vast amounts of data, understand the context, and continuously learn from experience. So we learn from experience. So in the cognitive computing, next. So overview of its evolution. The evolution of cognitive computing can be tracked back to the early days of artificial intelligence research. Next. While classical AI aimed to solve specific problems using rule-based systems, cognitive computing represents a paradigm shift. Next. It draws inspiration from the way the human brain works. This is what I said, how the human brain works, how the thinking process works. If you add to the present day artificial intelligence, you get cognitive computing. So it draws inspiration from the way the human brain works, emphasizing the importance of learning, reasoning, and problem solving. Next. Over the years, advances in computational power, data availability, and algorithmic innovations have propelled cognitive computing into a transformative force across various industries. Next. Foundations of cognitive computing. One is artificial intelligence versus cognitive computing. Next. So, interdisciplinary nature of that. Cognitive computing is the end of the beginning for the digital revolution. It will allow us to transcend the limitations of the current era of computing, where machines can only do what they are programmed to do. Next. This is given by a senior president of IBM. Next. In comparison, artificial intelligence versus cognitive computing. Artificial intelligence is a broader concept that encompasses various approaches to simulate intelligent behavior. Next. Cognitive computing is a subset of AI. This is also important to note it. Cognitive computing is a subset of AI specifically focused on creating systems that emulate human thought process. While AI encompasses rule-based systems and statistical models, cognitive computing emphasizes a more holistic approach, integrating multiple disciplines to achieve human-like cognitive ability. So, we want to become more and more human. So, you move from artificial intelligence, and if you want to approach humanism, then cognitive computing comes there. Interdisciplinary nature of that. Next. One key characteristic of cognitive computing is its interdisciplinary nature. It draws on insights from the computer science, neuroscience, linguistics, and psychology. This is also an important thing, So, if you want that, so you should go to the computer science, neuroscience, linguistics, and psychology. Natural language processing enables machines to understand and communicate in human language. Machine learning facilitates pattern recognition and decision making. And neural networks mimic the interconnected neurons of the human brain. Next. This convergence of diverse fields contribute to the richness and complexity of cognitive computing. So it is cognitive computing is convergence of big data, machine learning, natural language processing, and human-computer interaction. It is the ability of machines to interact with humans in a natural way using a natural language and gestures and to learn from their interactions. So, next. So this is by a senior vice president of digital of Anthem company. Next. Natural language processing. Next. Natural language processing (NLP) is a fundamental component of cognitive computing. Next. In cognitive systems, NLP is employed to process vast data, textual data, extracting meaning, context, and sentiment. Next. This capability allows machines to engage in human-like conversations, comprehend user queries, and provide the relevant responses. This thing we have already seen. Next. In machine learning, also you are familiar with that. Cognitive computing framework. Next. Next. Machine learning algorithms, etc. Next. Then neural networks. Inspired by the structure of the human brain, neural networks are integral to cognitive computing's ability to mimic complex cognitive processes. The neural network also is part of cognitive computing. Next. 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 So, and this deep learning is also part of that. Next. Mimicking human thought process. As I said, how the brain works and human thought process. If you also include with AI, you get cognitive computing. Mimic human thought process, understanding context, learning and adapting. Cognitive computing is the simulation of human thought process in a computerized model. Cognitive computing involves self-learning systems that use data mining, pattern recognition, natural language. These are all important subjects in artificial intelligence as well as computing, cognitive computing. So, self-learning systems, data mining, pattern recognition, natural language processing to mimic the way the human brain works. Next. Mimic, understanding the context. So this is another important feature of cognitive computing. One distinctive feature of human intelligence is the ability to understand and interpret context. Human beings, solve their problems depending upon the context in which something is, occurs. So the context is very important. So if there is one context, you act in one way. If the context changes, you act in another way. That is very natural for human beings. So cognitive computing, if you can do that, then it will be very good. So you will be, more nearer to a human, more nearer to a human. Next. Cognitive computing systems strive to emulate this capability by considering the broader circumstances surrounding data and the information interactions. Next. Next. Whether it is natural language understanding or decision making, the incorporation of context enhances the overall intelligence and cognitive computing. So if you understand the context, so you can solve a problem very easily. Next. Continuous learning and adaptation. Next. 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 So this continuous learning and human beings do. If you adopt it, then it will cognitive computing. Continuous learning and adapting. Next. Improved decision making. Advanced pattern recognition. These are some of the stages. Next. Data-driven insights. So cognitive computing is a combination of cognitive science and computer science. It is the study of how to build systems that can perform tasks that require human intelligence, such as perception, reasoning, learning, decision making, and communication. Next. This is given by the famous Marvin Minsky, so very famous in computer science. So he is the co-founder of the MIT's Artificial Intelligence Laboratory. So this is how he defined that in cognitive computing. Very interesting definition. Next. Then we will use advanced pattern recognition next. Next. Then data-driven insights, and depending upon the data also, so we solve problems. In the realm of cognitive computing, data is the cornerstone. Next. Cognitive systems leverage large data sets to extract meaningful insights, providing foundation for informed decision making. So ordinary decision making is there, and informed higher level stages also, decision making is also there. So it depends upon the data we are using. Next. Real world applications, here what are the real world applications of cognitive computing? So this is important. What are the applications? Is it just a theory? No, but it is not a theory. It has been used in several areas. One of the areas is healthcare. Indicated that healthcare. Second is finance. In banks and financial institutes they use. So healthcare, finance, customer service. So a company is there, the customers are there. In customer service, that area also it is used for cognitive computing. And in education, so you are all students. This audience consists of teachers and students. So it is used in education system also. It is used in entertainment also. In cinemas and so on. Entertainment also. Next. So cognitive computing is the ability of computers to learn from data and experience and to provide relevant and timely insights and recommendations to users and business. This is told by the former chairman and CEO of IBM. Yes. Briefly we'll see how it is used in healthcare. One of the groundbreaking applications of cognitive computing in healthcare. Next. You see, from disease diagnosis to treatment planning, cognitive systems analyze vast data sets, including medical records, research articles. They analyze research articles also to provide insights that aid healthcare professionals, the doctors. Yes. So cognitive computing ability is to understand natural language and processing unstructured medical data contributes to more accurate diagnosis and personalized treatment recommendations. This is how it is used in healthcare. Then disease diagnosis also is used. Go continue. Disease diagnosis. Next. Then personalized treatment of medicine. Personalized, so you have to consider on a particular patient what should be the treatment for him. And if there is another patient, it will be slightly different because you have to study his body systems, the data you get, and then change it like that. It depends upon the person. That is a personalized treatment class. Next. So this is personalized treatment class. Next. In the finance area. In finance area, there are different ways. Next. Finance. Next. Is the fraud detection, global advisors, so like that. Next. Risk management, etc. These are the areas in finance. Next. Then in retail, business. Next. Retail art. Next. Chatbots, visual search. price optimization and so on. And then importantly, fraud detection also, the cognitive computing is used. Enhancing security through cognitive computing. Next. Financial sector, cognitive computing plays a crucial role in fraud detection. Next. The real-time processing, fraud detection. Next. And investment strategies. If you want to invest in mutual funds and so on, then investment strategies. For that also this is used. Optimizing investments. Next. So this is investment strategies. Next. Customer service also it is used. These are words known to you. Customer service. Next. Okay. Education. Education. Example, there is one system known as Newton with K there, not the scientist Newton, but Newton's same wording, but K Newton. Next, Newton is a cognitive computing system. Newton can help students and teachers in various aspects of education, such as next. So Newton adaptive learning platform. Next. Newton Alta, Newton test preparation and so on. This is about Newton. Next. Second slide on Newton. Second slide on Newton. Go back. Go back. Slowly go. Next one. The improved learning outcomes and performance, increased motivation and engagement.